So we have this Kubernetes cluster, which is composed of a couple of nodes. Okay, it is a cluster on-prem, and it is implemented with a Kube-ADM. Okay, and we have several deployments, but we are only interested on this one, my server, right? My server is basically an API call whose name is login. I mean, it's a login API call that we are going to use for this demo. This deployment has only one pod, one microservice, as you can see here. Okay, and for accessing this microservice, we have defined a service. This service that, this Kubernetes service that you can see here is basically a node port service, and that means that the Kubernetes is opening this port, the 30,085, on every node of the cluster, so that the service can be accessed, or the microservice can be accessed remotely. If we want to see how this microservice works, we can issue a couple of requests using Postman. So with Postman, we can place here the URL. Okay, and we only have to give to pass in the body the username and password, and that's the credentials. And this login microservice only works with this username and this password, only with foo and bar. So if we execute it, we get the 200 authorized. And on the other hand, if a similar call with a different username or different password is executed, then we get a 401 not authorized. Okay. Also, in this demo, we have a FWB here. Okay, this FWB is a virtual machine. I mean, it's not inside the Kubernetes cluster. It is outside. I mean, it's working as an API gateway function. Okay, and the mission of this FWB is to protect the API calls that we will be issuing against the microservice, the login microservice that we saw before. So for that, we have configured the FWB like this. I mean, it's working in reverse proxy configuration. And that means that we have to define a virtual server. Okay, the virtual server IP is this one, the 192.168.140. We have also to define a server pool. As I mentioned before, we can see that the type is reverse proxy. And here in the reverse pool, in the server pool, we have to specify the port, the node port that we saw before in the Kubernetes service that we defined for the login microservice. We also have to define a policy that will allow traffic from this virtual server to this server pool. Okay, we can see that is properly defined here. We are also defining the HTTP and HTTPS services that we are going to use. And in this case, or for now, we are not setting any protection, any security at all. So in this case, the FWB will only forward traffic to the microservice, and that's it. So if we execute a simple brute force attack, we can see how easy it is to guess or to find out the credentials, right? For this, we are going to use Hydra. This tool is used basically to execute or to iterate through a number of different passwords that are being generated automatically. Okay, and these passwords and credentials will be executed on every login API call. So if we run this, we can see that a number of different possibilities are being generated. I mean, for the same user, the foo, we get different possibilities, and if we give it some time, by the time it reaches, it reaches this possibility, the bar password, then it will report or indicate that these are the proper credentials. Okay. So now what we are going to do is to go back to FortiWeb, and then we are going to change the protection profile. We are going to use this one, the standard protection. And we are going to repeat the same test. As we can see now, the test is much faster, basically because FortiWeb is protecting the microservice from the attack. It already went through the right password, but it wasn't detected. And also to show that we are not cheating here, we can go back to our Postman client and then execute a couple of requests. This is the correct one with the proper credentials. And we can still see that this one is returning a proper status code. I mean, the login is authorized. And if we execute the wrong one, then we still get the 401 not authorized. Okay, so that's it. Thank you very much.